This is lesson 9.5, completing the square. I would just like to remind all people watching this video that the unauthorized reproduction or distribution of this copyrighted work is illegal. Criminal copyright infringement is investigated by federal law enforcement agencies and is punishable by up to 5 years in prison and a fine of $250,000. Just kidding. If you want to reproduce or distribute or even charge for people to watch this video since it's so spectacular, feel free. Before we can talk about completing a square, we need to review what a perfect square trinomial is. A perfect square trinomial is the product of a binomial when it's squared. So x minus 3 squared, that would be x minus 3 times x minus 3. We want to multiply this, so x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And we'll combine our like terms to get x squared minus 6x minus, that's a plus, 9. Now, this down at the bottom would be what we call the perfect square trinomial because it is the trinomial that we get when we multiply a binomial by itself. Now, notice that c, or the last term here, is the square of half of b, which is the middle term there. So b is negative 6, and half of negative 6 is negative 3, and the square of negative 3 is 9. So, again, notice and remember that c, or the last term, is the square of half of b, or the middle term. So let's play around with this. If every time c is the square of half of b, let's find what c is for both of these equations. Here I know b equals negative 16. Half of b would be negative 8. And we want to square that. 8 times 8 is 64. So a perfect square trinomial would be x squared minus 16x plus 64. Now, a really cool thing to note is that when we factor this, this is going to be x minus 8 squared. Let's try the next one. X squared plus 20x plus c. Well, b equals 20. Half of b would be 10. We want to square that, and we will get 100. So that means c equals 100. X squared plus 20x plus 100. And again, if we wanted to factor that, we could go straight into x plus 10 squared. Now, where did I get that 10? Over here. Where did I get my negative 8? Over there. All right. Now, finding solutions is something we did last lesson, where we would factor the trinomial, then set each of those factors equal to 0 and solve. Unfortunately, sometimes our trinomial just isn't factorable. For example, x squared minus 14x plus 16. There's no two numbers that multiply to be 16 and add to be negative 14. So that means we're going to have to use completing the square. In order to do this, let's first make it look like a completing the square equation where we have to find a c. And we'll get rid of this 16. We already know it's not going to work, so we'll subtract it from both sides to move it over. And we're left with x squared minus 14x equals negative 16. Now, we want to manipulate the left side of our equation so that we can turn it into a perfect square trinomial. In order to do that, we need to find a number that is the square of half of b. So our b here is negative 14. Half of negative 14 is negative 7. We're going to want to square that, and that will be 49. So our new equation is x squared minus 14x plus 49. Now, if I'm adding 49 on this left side here, I have to do the same exact thing to the other side of my equation to make sure that it stays balanced. Remember, equations are just like scales. Whatever you do to one side, you have to do to the other. So if I'm going to add 49 to the left side, I need to also add 49 to the right side. If we factor out our left side, we will have x minus 7 squared, and that is equal to negative 16 plus 49, that would be 33. We can now go ahead and solve this out. We will take the square root of both sides. X minus 7 equals plus or minus square root of 33. If you have a calculator, you can go ahead and solve that out. If not, we can leave it in radical form. We then add 7 and add 7, and we get that x equals 7 plus or minus the square root of 33. And that is our final answers. Now, if you plugged in square root of 33 into your calculator, did 7 plus that, and then 7 minus that, you would get two different answers for your solution. So I know that last example was a bit rushed, so let's go ahead and try another. First, we must set it up as a perfect square equation, subtract 15 from both sides, and we get x squared plus 9x equals negative 15. Now, we want to figure out something that is the square of half of b. Notice here we're going to start dealing with fractions. b is 9, so half of b is 9 over 2. And we'll square that and get 81 over 4. So our equation now becomes x squared plus 9x plus 81 over 4 equals negative 15, which would be over 1, plus 81 over 4. Now, of course, since I put it over 1, you already know what we're going to have to do. Find some common denominators. So we will multiply the top and the bottom by 4. And we would end up with negative 60 over 4 plus 81 over 4. Now, working all this out together, what is our new equation? Our new equation is, probably shouldn't write in green. Our new equation is going to be the factored x plus 9 over 2 squared equals 21 over 4, which is, again, just that combined. Solve it out to find our solutions. We'll take the square root, and we have x plus 9 over 2 equals plus or minus square root of 21 over 4. We'll subtract 9 over 2 from both sides, and our final answer is x equals negative 9 over 2 plus or minus the square root of 21 over 4. And that is a perfectly acceptable answer. If you wanted to simplify the square root of 4 to just be 2, that would work, but this is perfectly acceptable. If you wanted to plug it into your calculator, fine, but again, this answer, perfectly and totally acceptable. The last little thing we're going to talk about is the vertex form of a quadratic function. Normally, our quadratic functions are in this form of y equals ax squared plus bx plus c, and if we wanted to find our vertex, we would do negative b over 2a and then plug that value of x into the equation, yada, 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 stuff we did a couple sections ago. Well, now we're going to look at a new form. It's still the same equation. It's still going to give us a parabola, but instead our form is y equals x minus h squared plus k. And in this form, h comma k is going to be our vertex. H will be your x value, and k will be your y value. Now, doesn't that look very similar to completing the square equation? Well, if it doesn't, so let's remember our equation from that last slide. Write it off to the side so that we can remember. Y equals x minus h plus k. And we want to move our equation around to look like that. So while we could look at this and we could factor, that wouldn't give us the vertex form. This is just a little shortcut to getting the vertex. If I want to get the vertex, first let's subtract 8 from both sides so that I can do my completing the square. Now to complete the square here, I need the square of half of b. So half of b is 6, so the square of that would be 9. So I'm going to add 9 to both sides. When I do that, I get y plus 1 equals x squared plus 6x plus 9. Now let's do a little bit of factoring. We get y plus 1 equals x plus 3 squared. And then I can subtract 1 from both sides, and I get y equals x plus 3 squared minus 1. Now this certainly looks like it's written in that form, so I can easily pull out my vertex. If it's supposed to be x minus h, that means my h is negative 3. And if it's supposed to be plus k, that means that my k is negative 1. And that is my vertex. I hope that this video was helpful. Again, if you haven't finished your bowl of popcorn that I'm sure you popped for this video, go ahead and watch it again and just mow down on all that popcorn. Otherwise, I have a joke for you. Why did the scientist install a knocker on his door? He wanted to win the Nobel Prize.